Now you might ask, aren't these raw materials critical because we're going to run out due to their overconsumption? Well, as illustrated in another video presented by the British Geological Survey, the answer is no, not for the time being. There's been a lot of talk in various media about depleting the so-called raw material geological reserves, but you must understand that these reserves are by no means all the raw materials that are out there. It's a bit like in this slide. The reserves are the portion of the mineral resources already identified by miners that they know they can get out of the ground at a profit. But if there are no more reserves, then the prices of raw materials go up, and then it becomes worthwhile for the mining exploration companies to go out and look for more. And there's a lot more to be found if you look for it. Of course, it might be more expensive to get it out because the easy deposits have already been discovered, and that influences criticality. So what really drives criticality isn't geological availability in the sense of how much is still in the ground, but rather a variety of factors that influence the access to raw materials. Access is influenced by economic, geopolitical, environmental, social, etc. factors, and all that goes into the criticality assessments. You might also wonder why we need to extract these mineral raw materials in the first place, rather than simply recycle them. Well, recycling is definitely part of the solution to the supply issue and also to environmental issues. But you must realize that when the demand for a raw material is rapidly increasing, as is the case for these critical raw materials, recycling can only satisfy part of that demand. This is because when you buy a product, you don't immediately throw it away for it to be recycled. You use it and only discard it after a certain time. But during that time, demand has increased. So when your product becomes waste, that waste stream can only cover part of the demand. This is a very important point to understand, and it is not intuitively obvious, so let's go through it together. Let's consider copper production. Copper production has shown a remarkably stable increase of around 3% a year since over a century. Now let's assume that copper is used in the economy, for example as cables in buildings, for approximately 20 years before it becomes waste. In 2020, our copper demand is, say, around 20 million tons. This copper will only become waste in 20 years, but by that time, demand will have increased, and so it is higher than the copper waste flow. So there is always a lag between demand and what the waste flow can provide. The difference between demand and what the waste stream can provide has to come out of the ground. So when demand is high, primary resources, those that are extracted from the ground, cannot be avoided. That puts the emphasis on one of the pillars of the circular economy, namely sustainable supply. It puts pressure on the extractive industry to reduce its environmental and social footprints at all stages of a mine's life cycle. And we'll be talking about that in another video.